Good afternoon, everyone. It's been 2 amazing days of SRE chatter in London right now, and yeah, we've heard some really good, fascinating talks with from some really delightful speakers. But I'd like to continue this momentum a little further to the very end and help you get away with a little more energy than right now. So we're going to talk about how a little misconfiguration, actually a group of misconfigurations in our long-term Prometheus metric storage, almost cost us over $100,000. So yeah, let's just dive right into it. So who are these two men in black? Well, we're Shubham and Deepak. We're part of the founding team at ZenDuty, an advanced incident alerting and response architecture platform. We have years of experience making mistakes, learning from them, and advocating for best practices for org setting up their DevOps, SRE, and production engineering teams. So what is this talk really going to be about? Well, we'll firstly address why we needed a solution like Thanos in the first place. And then we're going to discuss how Victoria Metrics, Cortex, and the other solutions that are in the market right now compare to Thanos. What our proud setup was and what were our expectations from it. And then the good, the bad, and the ugly. Not the Eastwood movie, but what really went wrong, how we fixed it, and how much it could have cost us. So why would we need Thanos again? Prometheus has a simple and reliable operational model. It's capable of tracking millions of measurements in real time and with powerful querying capabilities, and via Grafana, good visualizations as well. However, past a certain scale, it has certain shortcomings, and these shortcomings, these are very apparent. It fails to answer a few questions that fast scaling teams naturally come across. Questions like how can we store petabytes of data in a reliable and cost-efficient way? Can we do so without sacrificing the response query times? Can we access all the metrics from different Prometheus servers from a single query API? And can we somehow merge replicated data collected via Prometheus HA setups? And turns out Thanos is a solution to all these questions. So a few of the major reasons we liked Thanos was, first up, the global query view. So Prometheus encourages a functional sharding approach. So even a single Prometheus server provides enough scalability to free your users from the complexity of horizontal sharding in virtually all use cases. But regardless, you would still want to access all of this data through the same API or UI, and which is the global view that we were talking about. So for example, you can render multiple queries in a Grafana graph, but that can be only done against a single Prometheus server. So with Thanos, on the other hand, you can query and aggregate data from multiple Prometheus servers because all of them are available from a single endpoint. So next up, we have reliable historical data storage. So Thanos Sidecar watches Prometheus for new blocks of persisted data and uploads them into an object storage bucket. So for us, that was AWS S3. You can go with any cloud partner of your choice. Next, we have good old downsampling. So once you start querying historical data, you'll notice that there are fundamental big O complexities that make your query slower and slower as you retrieve weeks, months, and eventually years worth of data. And the solution to that problem is downsampling. So the process of reducing the sampling rate of the data that we have. So with downsample data, you can pretty much zoom out to a larger time range and maintain the same number of samples, thus keeping your queries responsive. And lastly, we have high availability. So Prometheus has an HA model that independently collects data twice. And it is as simple as it could be. However, the merged and deduplicated view that of both data streams that Thanos provides is a huge usability improvement. So there were quite a few solutions when we were choosing tooling, and we considered a few of them, but some of them were either a little too immature, not community-driven, they didn't support PromQL maybe, they didn't have object storage, or plainly the integrations with the rest of our observability architecture wasn't as delightful as it was for Thanos. So naturally, we went to where all the cool kids were, and we went to Thanos. So let's take a look at how we implemented Thanos. So it's a beautiful Titanic before it hit the iceberg. So Thanos runs as the sidecar to the Prometheus instance, and it pushes blocks of data to the object storage, in our case again S3. So we had implemented Prometheus functional sharding in the HA mode, which means we were scraping the same data twice from different daisies. The setup required a Thanos ruler to set PromQL equations for alerting, and the ruler should be connected to the alert manager. so that it could send the alerts to any external alert managers as well, any other destinations. And then Thanos Query is used by the teams for any analysis or for creating any dashboards for the team members or the PMs. Query again uses the Thanos storage gateway over there and to get old data from the object storage. And in order to get faster query results, the Thanos Compactor is used to downsample the data and store it back to object storage. So now let's see how we had log aggregation set up via Fluentbit, or as I like to call it, the other bird app that we should be talking more about. So Fluentbit is a well-known log aggregate used for Kubernetes. We deployed a daemon set and started exporting the logs to OpenSearch. And Fluentbit uses a plugin to add extra labels to the log line for each log stream that you're pushing. But for getting the extra labels like pod name, namespace, annotations, and other relevant elements, it calls the Kubernetes API for that information. And if the KS API fails, there's a small jitter, but eventually it gets to that. So our expectations, we were like, we've spent some time into this, we've done research. We're definitely expecting effortless querying, cheap long-term metric storage. We're going to downsample data as much as we want, whenever we want. And we're just going to enjoy this cleaner metrics and logging system. And it wasn't as easy, but we got it all configured, right? So should work without a hiccup? Not really. Didn't work. And we saw a bunch of anomalies and errors popping up that we couldn't really make sense of initially because we were not expecting this to happen, and until it all came together. So firstly, in this series of unfortunate events, we had an issue with our network topology. So while we were building a log and metric handling infrastructure, we missed to keep in mind some basics that cost us daily. Next, our good old downsampling, a friendly neighborhood downsampler. There was a mismatch in our implementation and the expectation with downsampler, causing an increase in network and storage costs. And lastly, just plain old high cardinality. We had too many metrics to monitor and scrape. Too many talks today were about cardinality as well. Is Piyush here from last night? No. Cheers to him. But yeah, I'll pass the stage on to my friend Deepak now. Who was off the deep end when all of this transpired, and let's see what he found when he dove in.
Hi everyone. So let's go ahead with the problems, right? Which we were facing while we try to set up logging metrics like 3 observability, what do you say that verticals. So what went wrong? The first thing that is the networking topology, right? So when the guys pitched in, and there were a number of guys that they were focusing on just setting up the 3 pillars of the observability, and they were not looking back like what they have missed before. They just talking about the connectivity and everything else, right? So this is a basic US East region, right? And this is there are 3 subnets in the public and there are 3 subnet in the private, but there is a catch here that only most of the clusters are present in the private when you are in a SaaS product, and you provide connectivity through NAT, and from NAT every egress counts and it's cost, okay. And most of our metrics data is getting dumped into S3, right? So that is actually was an issue. So nobody actually realized it unless we actually looked into it. So engineers were like, why this is an issue, right? So actually they forgot about the basic of what do you say, AWS architecture, 5 pillars. In that, if you just add one VPC gateway endpoint, right, and provide a private connectivity to S3 or Dynamo, this actually reduces cost. So this was really efficient way to do it, that this is supposed to be done like way before they started implementing the observability thing. And the next thing was the downsampling. Yes. So if nobody knows what the downsampling is, it's basically if you have let's say in a minute you're scraping your targets at every 2 seconds, then you have almost 30 samples, and you want to downsample that that data, like you took the data for like 10 minutes or like 30 minutes, then you are actually reducing the number of samples in the time range. So if you see here, this will look familiar with the with the configuration of Thanos, right? Thanos Compactor, which is actually connected to S3 for compacting the raw data and everything. So these are the three major configuration impacting the downsampling and our needs. So they were so let me explain what's actually that means. That retention resolution row actually means that in starting that they were actually want to retain raw data for 40 days. Okay, so and after that they want to downsample to the 5-minute resolution of and they want to retain that till 180 days. But the retention, right, after 40 days it will start downsampling. That's what the that's what how Thanos compactor is designed. So they didn't account for downsampling it earlier, which actually cost us some more. And in the last, they were accounting after 180 days. They want to downsample it to 1 hour so that they can go with the years of data, and they don't want to expire it. So that's pretty fine with me, because that's 1 hour. That's not going to be a problem for me. But they didn't. What they didn't account is there will be a time that you are actually getting current real-time data, and there you are actually compacting the old data. So when you are actually throwing data towards S3 and getting it back, bandwidth usage and everything, egress, if you are not if you have not corrected your topology, that will actually going to cost. So for fixing this, we came up with something with our own flavor of compactor actually, which is derived from Thanos Compactor itself. So in this we provided there is something called as some constant that we provided for as a risk prevention for the not cost us much. And we hard coded some of the constant, and we provided flexibility for the teams, so they can change how they want to downsample and when they want to start the downsampling. And there are some catch in it. So every raw data that is getting dumped into S3 will be present for 3 days, regardless of if it is downsampled or not. Okay, and we are providing in this custom compactor configuration, according to teams, they can retain custom resolution to the custom time. What I mean is like for the teams requiring custom downsample data like 10 minutes, 30 minutes or 1 hour, provide custom retention period. Okay, so it's not hard coded like in compactor you can only do 5 minutes or like 1 hour, 10 minutes. But here you can define the duration and resolution time according to your needs. So there is a catch in it. The catch is there is an extra label with it. So when you want to start this resolution, right, like you want to downsample to particular 10-minute resolution, right, but you have to start it within the three days, right? Otherwise the data will be deleted and you won't be able to downsample it. So, and there is one more catch, like if you want to downsample the data from raw to 10-minute resolution and from 10 minutes to 2 hours or 30 minutes, right, that is possible. But there is only one condition: the data like 10 minutes data should be present, 10-minute resolution data should be present prior to if you are resolving it to 30 minutes. So that's like a thumb rule. And if you resolve resolve it to the bigger period, the automatically older period will get deleted. That was a catch. So it actually helped us reducing load of object storage and make much more sense for our teams, and which actually gives pretty nice results for us. And soon it will be open source. We are planning to make it as a flavor of ours, and if somebody wants to use it, they can use it. But right now it's not there, so that's a different thing. So that was not the only fix. There are more to it. So the thing is with the cardinality, right? So cardinality is basically the size of a particular data set, right? So that was the issue. There was some constant that some teams were adding dynamically. So we limited that, and we made sure that there is a proper guideline for adding some extra labels and extra label values to a particular matrix. Otherwise, there will be a hell lot of cardinalities, and which means if there is a high cardinality, then every time you are scraping more data and you're dumping way too much. And that's the example of it. So if a server response and the server code and environment are two label names, and then the label values, you can make the combinations here, and that combination actually makes the cardinality for a particular matrix. So this taken into this, we as an engineering team, we would have taken it way before then, rather than just implementing the observability in 3 platforms, 3 pillars of it. But somehow we made sure that there is a particular limit on it, though up to till what cardinality a service can go. Okay, we have few millions. Okay, that's not it's not small, so chill about it. So there is not a big issue at that moment, but still it might be, if somebody adds unnecessary labels or values, or that dynamically labels or values basically. So these are the 3 metrics problems that we solved at that time. And after that, while we were solving it, right, suddenly we started popping some alarms, and that has nothing to do with the metrics. And we thought that is something to do with the metrics, that we are putting something on which is not supposed to be there. But Fluentbit, we suddenly seeing rise in memory, and after we ignored and we tried to solve it, and we suddenly seeing that our data aggregator that we are using is generating anomalous log. Okay, it's not pattern driven for the different cluster, and it's not in a particular cluster, it's in a different AZ also, on a different region. What I mean is that, and when we debugged it at the time of after we were implementing the same thing, and at the time of it was actually in the real time. So we found out that there was a issue with the Fluentbit actually getting connected to the API server. It's so what actually happens is, right, so Fluentbit actually tried to tail each and every line of the container logs, and it adds the extra labels to it, using the API server, right. It calls the Kubernetes API server, and it's actually try to add it, and but it was not happening. So it was actually using our API server, Kubernetes API server bandwidth and everything else. So we found out that there is a new developer came up with the new filters, and forgot to put subpath. He accidentally put subpath as a mount to the Kubernetes pod, so which indirectly didn't refresh the Kubernetes certificate so that it can get authenticated to the API server. So that was the issue. So in order to take care of this, we actually came up with a pretty tight that GitHub flow, go ahead with the what your manager has to say about it, your seniors has to say about it. Then only we only provided particular permissions for a developer, so up to what they can add and what they can't, and we were pretty fine after that. So that was a issue, anonymous issue, but it's very funny. Shouldn't have happened. So thanks to our something proper alerting, so we were able to catch that in almost 3 to 4 days. So I won't say we caught it on the first day, but that actually costed us because of there was some alerting. So people actually was fine with it because but nobody after everything goes fixed, then everybody started noticing like what it would have costed us, right? how much it would have costed. They were just thinking like very small amounts and all. Then we started estimating costs. Like after that, we are doing RCAs and all, right? So let's get into the cost that what costed actually. I am giving the rough analysis, but the RCAs is much more than that. For the single cluster monthly that we were running, the data processed for that particular amount of time, that chaos that they created, that would have estimated to 50 TB around. And if you take it per NAT, then the calculation is below. So it will be costing around 14,000 dollars. So that's way too much. That's only calculating the bad network configurations and everything, and that is chaotic. And everybody should actually first see at the AWS pillars, architecture pillars, before implementing basic things. And for the logging, that for the new developers, and it actually costed a little less for the same time, because there was a release related at that time, and almost 108 GB of data that got dumped into the AWS CloudWatch logs, and that again that get ingested into S3, and that have costed us at the same time. And don't worry, now we have enabled some alarms on AWS CloudWatch logs also, which was supposed to be there, but it was not. So you can see it is 1717 around. So that's not much as compared to the other one. And at the same time, we were running 7 to 8 clusters, so it's catastrophic. It was a kind of nail biting when you're not able to solve what actually is going on. So final words from my friend.
So now that we nip that in the bud, a few notes that we'd like to leave you all with. So firstly, the smallest mistakes that you can make are the hardest to notice. So you're not going to be looking out for these. You're probably not even expecting to make these. So they're in turn more expensive. Always remember that evolution forged the entirety of mankind with a single tool. That was the mistake. So don't count it out. Secondly, don't rush into things because it might be easy to drop in. I'm hearing a lot of chatter about people, shifting vendors right now, exploring new open source solutions in the past year or two, and I'm all for that. But do your due diligence before you're gonna adopt something. Nothing is really a silver bullet anymore, and just because it's a perfect fit, that doesn't mean that it's gonna be solving all your problems. And lastly, if you're one of those rapidly build fast, break fast teams, it's worth spending on extensive monitoring and alerting regardless of your scale or size. So even if you're just starting up and you feel that you're not there yet, it's pretty much worthwhile to spend some time into good monitoring. And of course, huge thanks to all the open source contributors at Thanos, Fluentbit, and all such open source projects, making the lives of us SREs much easier. And that's all our time. Thank you all for listening so patiently to this final talk at this lovely event. We can now entertain a few questions if there are any.
Hey, so you folks mentioned that one way that you resolved anomalous logs was you got a review process where before adding logs, if I understood correctly, you would make sure that you get approval from your managers or your code reviewers. Can you please expand a bit more onto that? Was that a standardized process? Was it as part of the code review, and how do you plan to scale that for larger teams?
Yeah. So that's a good question actually. So what actually happened at that moment was the new developer was writing some new service, so he actually wanted to write a different parser than what we actually had. So he accidentally committed subpath for that. So that usually we don't SRE teams or platform engineering teams don't review all that, because that's a smaller thing. So we don't care. We much care about just making sure that the site is up, and making sure that we are not throwing enough 500 so that we get a lot of customer calls. So in order to escape what the review process actually came up with the what do you say, leads were assigned for a particular developers in order to review their codes, and file permissions were not given to the developers anymore now, which changes anything that can create or anomalously dump large data into something, and that is one of the point. And only if you want to get approved some new parsers or anything else, you have to go through the platform engineering team. So because I get it, new engineers and new developers actually have all that pumped in inside. Let's get it through. Let's release this feature as fast as fast. So I get that, but there has to be a process, so everything has to be get through approvals. So after this incident, we have taken away a number of permissions from which can impact our cloud ingestion logs, or basically any egress traffic that we are sending out. So that was one of the process. And for the large enterprises, right, I would like to recommend so one thing is basically provide what is necessary for the developers. Okay, don't give them excessive what they know a little about. Okay, if you're giving them more views, some people might accidentally create this kind of issue. So there has to be a process, or another way to deal with it. So you can't actually get your director into it. So that's a different way. So that's how I like to go with it. So either either you provide something in access to it, otherwise don't provide at all, because if you are not confident enough on that on that team or anything else, or design a separate team for it. So that's what.